We think of water as an ordinary substance, but it's anything but. The surprising truth is that this abundant compound doesn't behave the way most substances do, and its chemical and physical oddities are the key to its role as the matrix of life. We think nothing of the fact that ice floats on the surface of water. That happens because water expands when it freezes, increasing its volume by 9% and becoming less dense. This is just one of water's properties that sets it apart as an oddball.
Most substances, unlike water, are much more dense in their solid form than in their liquid form. Glacial acetic acid is an example of that. Here we have a sample of its solid form, and in these beakers we have a sample of its liquid form. As you can see, solid glacial acetic acid acts very differently than water does.
Yes, this is how so-called normal compounds behave. And if water wasn't such a rebel, the consequences would be catastrophic.
If water behaved like most substances, if frozen water were more dense than liquid water, then every year when a pond froze over, it wouldn't freeze over, it would freeze under. And the ice would sink to the bottom of the pond and then build its way up from the bottom to the top instead of from the top to the bottom. All the life in that pond would die because it wouldn't have any liquid water available to it. Nothing could survive. So the fact that ice is less dense than liquid water enables life to carry on even when temperatures shift and get cold during the winter.
What's responsible for water's wackiness? At the molecular level, it's electrically lopsided. The H2O molecule looks like Mickey Mouse ears, with a slightly negative charge near the oxygen atom and a slightly positive charge near the hydrogen atoms.
Hardly anything has this great big negatively charged atom with these two little tiny positively charged atoms. It's what we call polar. It aligns itself in certain ways.
When two water molecules are going toward each other, they have to orient themselves so the positive portion of one water molecule is pointing toward the negative portion of another water molecule. This attractive force between the two molecules is what we call the hydrogen bond. And it's the hydrogen bond that gives water all of its unusual properties.
The hydrogen bond compels water molecules to grab onto one another, accounting for another of water's curious attributes.
Steel is more dense than water, so we wouldn't expect anything made of steel to float. We would, in fact, expect it to sink, like this steel paperclip. However, if we very carefully take our paperclip and place it just on the surface of the water, we'll find that it will float. You'll notice the subtle indentations that the paperclip is making in the surface of the water. This is because water's high surface tension allows the surface to act as if it were a skin.
We see water's high surface tension in action whenever we overfill a glass. The molecules cling so tenaciously to each other that the water can rise significantly over the brim. Water surface tension explains how some insects can walk atop ponds and lakes. It gives raindrops such a thick skin that they fall like bullets, whittling away mountains over geologic time. And it enhances water's ability to ascend through the capillary systems of plants and trees.
If water didn't have the fabulous surface tension property that it has, trees would be little stubby things, plants would be shorter, the very surface of the earth would look completely different.